select your mannequin character. I'm going to add it to its own collection, and let's isolate it. First, let's remove what we don't need. Anything after those points on the end won't be useful. Then I want to remove all those sharp edges. Just Alt-Shift-Select those edge loops and dissolve edges. Now let's separate the different parts. For the head, I will just want to make a cap. So I can delete this, and anything that is in between. Now let's separate the short and the shirt. Hide this line, select the bottom, and split this. The short I will cut off around this point, and the high socks will start around here. So all that is in between can be removed too. Then this shirt will be tight, but not that tight. So I can go to the Sculpt tab. Just make sure you disable all the armatures. And under Object Data Properties, we can clear the custom split normal data. Let's quickly complete this cap by flattening the bottom and extruding some parts. I can separate the cap from the rest, rename it cap, and add a solidify modifier. Also separate the mesh for the socks. Right, let's enable back all the armatures on the cap and the socks, as well as the cloth. I can also rename the base texture to cloth, and in the shading tab, I can just remove everything which was here originally. And let's just start with a darker value for the color. Now, before moving on, the character mainly needs some shoes. So for this, the easiest step is to take our socks, select everything in the bottom, duplicate it, and press P to separate that. So this will be our shoes. Under edges, clear sharp, make it easier, let's work with a single foot. For this one, we can remove all the vertex group, which doesn't concern the right foot. Just like this. Let's just dissolve a bunch of vertices. By comparing it with the original socks we kept from character, we can sculpt it to be around the foot in a nice way. Now you just need to keep a shoe as a reference to sculpt this, so it will look fine. Also, we don't want any part of the original mesh pushing through. Alright, this is it for the base shape. For the sole and the rest of the shoe, I am using the method popularized by Derek Elliott, which simply consists of duplicating the bottom part of the shoe and adding a solidify modifier to it before starting sculpting the shoe itself. Then for the other details, I can simply add or remove faces, duplicating it and extruding. By duplicating parts of the shoe, I can keep the vertex weight that were originally here. For the laces, I can simply add an extruded curve, which I am drawing on top of the shoe. For the trims, I can duplicate some edge loops, convert them to curves, and extrude them. And for the bottom parts, I simply select a few faces and extrude them individually. And in the end, I am applying all the geometry modifying modifiers, so I can combine everything into a single object. For the materials, I am adding really simple plastic materials to the soles. And for the cloth parts, I'm making a really crude cloth material using a brick texture to drive the height of a bump node. I also had to UV unwrap my shoe so I could add my logo on it and make it look more like an off-the-shelf shoe. And as the rest of the project, it doesn't really need to look good up close. In order for the shoe to work well with the armature deform modifiers, we have to fix all the vertex weight for the new parts of the shoe. So for this, it's a bit of trial and error to try and copy the vertex weight that were originally on the feet to the different part of the shoe. In the end, I also added a mask modifier to hide the original feet of the character and make sure they never clip through the shoe. And after a bunch of tweakings, the right shoe is ready and I can just duplicate it and mirror it for the left shoe. While also making sure to rename the vertex groups. Now for the rest of the cloth. The first step is to UV unwrap everything again, because when we dissolved the edge loops around the shoulders and everywhere, we messed up the UV map. So we have to alt select some new edge loops, mark them as seams, and UV unwrap everything properly again. Then I want to base all the cloth textures on 3 different texture maps. One for the bump, around the seams and everything, one for the color, with the different shades of the gray, and some parts to have some kind of honeycomb transparent materials. So instead of having 3 different maps, I will simply create a single map and use either pure green, pure red, or pure blue to assign the different maps that I want. I do this for the main cloth, as well as the socks and the cap. I am using some different mix modes for the textures, so that in some place I can mix between them, and in others I can just add them all together and have all the effects in the same place. Then in the shading tab, I can separate all my different materials, put the blue channel at the height of a bump node, the red channel will be used to mix between 2 different shaders, and the green channel as the base color of my cloth. I create my honeycomb texture with the Voronoi texture, which is rotated a bit, so that I can have this meshed effect. I am setting the roughness pretty low and the metalness pretty high to emulate the kind of look we have with synthetic materials. And at the final touch, I add some really strong Fresnel effect to mix between the full white material near the edges and the original texture in the middle. Now, to add a bunch of realistic details without needing some cloth simulation, we can add something called a wrinkle map, which will kind of fake all those tiny wrinkles, which will be perfect for our character which has some sportswear. I only want the wrinkle maps to be made on the body and on the main cloth. So for that, we first need to store an undeformed part of this mesh. Make a link duplicate with Alt-D and rename it cloth undeformed. On this one we can remove all the modifiers and store it into a new collection called undeformed, which you can hide. Now on the main part of the cloth, we can go to the geometry node tab and add a new geometry node modifier, which will be the wrinkle map. Basically, we will just compare the area of the faces from this deformed mesh to the undeformed mesh. If the area is smaller than the undeformed mesh, that means this part has shrunk, and if it is otherwise, it will mean that the part has expanded. So let's add an object info node and target it to the undeformed mesh, which we can put as a new input. Now basically, the index will link the two different things, so we can add a sample index node. In the index input, you can put the index, and the value we want to sample is just the face area. You can add two store named attributes nodes. One will be the wrinkles compression, and the other wrinkles expansion. To compute the difference of area, we can just add a subtract operation and set it to clamp. And if we subtract the undeformed mesh area from the deformed mesh area, this will be the zones that are expanding, and the other will be the compression, as you can see here. Now, if needed, we can scale this, so add some math operation set to multiply, and set those two values as new inputs, which you can call expansion scale and compression scale. Now let's go back to the shading tab and fetch those attributes. We can simply add some attributes node set to geometry and with the name we set before, and we can add a bit more resolution with the subdivision surface modifier just before on the deformed and undeformed mesh. Now the factor of this will drive the factor of mixed nodes, which can then be added together to drive the height value of a bump node, which plug before all the other bump nodes. Now we just need to set some noise pattern, which will be driven by the UVs, and to make it more stark, we can add some color ramps and set it to B-spline so it's a bit more eased. Now let's add a vector math multiply node in between here, so we can compress the value on one axis. And if you take a look at the result, it's already pretty convincing. We can add a math multiply operation for each channel to reduce the effect if needed. For expansion, it will be the same, but in the other direction. Now we have some nice dynamic deformation without any simulation, which of course breaks apart if you are looking really close, but from afar, it's pretty nice. And the effect is quite cheap to implement. Now this is a bit messy, so let's tidy up everything. Now let's move on to the trail vest. The method will really be the same as for the shoe, which means duplicating some part of the mesh so we can keep the vertex group weights and adding some more geometries until you get what you want. So let's get into time-lapse mode again. Here I am using vertex colors to differentiate between the mesh parts and the normal cloth. And I am just putting my logo on the back of the trail vest. Duplicating some geometry to add a water bottle. For some more details, I am quickly modeling some folded up running poles, which I will be adding to the training vest. I simply parented my poles to the vest using vertex parents so that they can just move along with the vest as a single solid object. And finally, we also need to fix the vertex weight on the trailing vest. Now that everything is starting to look really good, it may be time to start working on the lighting and general composition. First, let's set the camera to a portrait. For the lighting, I like to work on the animation tab just because of the default side-by-side view. And I am just moving the camera view slightly in front of our character. Now for the lighting. And I like to start with an environment which is completely black. So set the world strength to nearly 0. Now for this, because of the natural vibe, we will start with the sun. I'm going to put its strength around 10, and the angle, I would like something a bit bigger, so it's a bit softer lighting. We can rotate it. Then let's add some point lights to really emphasize some of the aspects of our beautiful textures and everything. Also, make sure that all the lights are put in the environment collection we made before. The first point light I'm adding will be a rim light to add some lighting and interesting reflection at the bottom of our piece. For this, I like to put a really high strength and the radius a bit higher. Then add another light, which will act as the first fill light, and this one will be on the camera side, and it will be the first light that will try to add some light on our character. Regarding radius, you can go with something a bit higher, so it's a bit softer, and we can put it a bit lower. And then the final light will be a strong light in the front of the character, so this will be the key light. Again, I'm putting a bit of a higher radius, so this really brings some definition to our character, while still keeping a nice shadow on our side. A final touch for the lighting of the scene, if like me you have some shiny elements in your scene, is to add an area light right beside the camera so that the shiny part will have something to reflect. Let's add a constraint so it's always tracking the master element of our scene, and let's move this around until it catches some reflection. And I can reduce the strength so it does not overpower the rest of the scene. Let's make a test render to see how it looks with the final subdivision, resolution and everything. Alright, it's looking pretty nice. I'm still not really happy with the size of the grass, so I'm going to tweak this a bit. Great, now let's export the first animated test. Straight away I will work with OpenEXRs. Now before launching an animated render, we need to make sure that we bake everything, so let's go again through the different steps. First we need to bake the terrain, then the strip time, and next we need to rerun the script to animate the strip time. And now let's try that render. And that's it for this part. Hope you learned something here. In the next part we'll add the base of a biome system and a procedural wooden bridge to our environment. Feel free to reach out to me if you have any question. Thank you for watching and see you next time.